Dr. Mark Shangizi here with your Science Moment. Today I'm going to talk about a special kind of illusion, or a category of illusion, or two categories of illusion. And they concern perception of motion, and these are sort of motion illusions or movement illusions. Most of us would imagine that the perception of motion is just the same thing as the perception of the change of position over time, because motion just is delta x over delta t. But we learn in the neurosciences and sort of perceptual psychology has learned over the years that the way the brain processes these things is quite different. You can actually perceive motion, but not perceive things to be moving anywhere. And you can also perceive things to change position over time, but to have no perceived motion. Right? These things are separable. Your brain has areas which are devoted to the position that they're in your visual field, where they are, and your brain has other areas devoted to the movement that they possess, the motion that they possess. And they're different, right? And so they're separable, they're dissociable. And so let me give you an example. This first example is, this comes from my earlier book, Vision Revolution, on a number of discoveries in and around vision. And this one concerns my theory concerning why we perceive illusions. It's sort of a grand unifying theory of illusions. It's about your brain having certain finite delays, and your brain has to correct for that. And so it always wants to anticipate the next moment, because by the time it's created a perception of the next moment, well, that moment has arrived, and so you have a perception of the present. So I'm not going to focus on these sort of grand unifying theories here. I just wanted you to look at this illusion. Hopefully you've been staring at it. And as you've been staring at it, you may have noticed that you perceive motion. It's just an image. It's not a video. It's just an image. But because it has cues of blur cues, and blur cues happen all the time when we move, and that suggests to your brain that these things are moving in the direction that the blur indicates. They're never moving and changing in position over time. They're kind of all stuck in that one spot. They never shift relative to the other objects, yet they're always moving. So here we have perceived motion without any perceived change in position over time. Okay. So this is the first case. Now, recently floating around the internet has been this illusion here, which I'm going to pop up on the screen. Now, when you just look at it, nothing interesting is happening. You have perceived motion. But what I want you to do now is start wiggling the camera. Start wiggling the camera. And when you do that, the first thing you're going to notice is, oh my God, nobody's moving anymore. I have no perceived motion when I start to wiggle it. The motion perception is gone. But one thing that people haven't looked at when they've been sort of sending around this viral video is that you still are having perceived changes of position. So for example, there's one really white figure, like a glowing white fuzzball, that starts sort of in the middle or to the left, and it just moves to the right. Focus on that, or focus on any of them, doesn't really matter. And then just, even while you're shaking it, even though there's no perceived motion, you will notice though that that one thing is in a different position over time, yet you perceive there to be no motion, right? So again, we have now two kinds of experiments that show you that perception of motion and perception of change of position are dissociated. They are not the same mechanisms by which we perceive them. They're fundamentally differently processed, and you can perceive one without the other. And that was your Science Moment. If you're interested in things like this and deep questions about the evolution of vision, why we see illusions at all, why we have color vision, why our eyes face forward, it's not because of predators and all these old ideas, and numbers of ideas like this, and it's a really fun read, my second book, Vision Revolution.